Welcome back. I am going to solve some examples of geometric series, and how to find the sum is we have S sub n, or the sum of a geometric series is S sub n is equal to u sub 1 multiplied by r sub n minus 1 divided by r minus 1. Okay, or the other way around, S sub n is equal to u sub 1 multiplied by 1 minus r raised to n divided by 1 minus r. Okay, let's see what we can find here. So you need u sub 1, that is 2. You need also r, that is, if we're going to divide 6 and 2, then we have 3, and then 18 and 6, we also have 3. It's good to do 2 or 3 so that you're very sure that you have a geometric sequence there. Because if it's not a geometric series, then you cannot use the sum of a geometric series, the formula, of course. And now we have our n. Our n is 12. So we're ready. S sub n is equal to u sub 1, that is 2, multiplied by r, we have 3 raised to 12 minus 1 divided by 3 minus 1. And this is also 2. So that is 1. It will become 1. So we have 3 raised to 12 is 531. 531,441 actually, but we have minus 1 there, so it should be 531,440. Okay, another, sorry for that. Okay, another example. Find the formula for S sub n, the sum of the first n terms of the series n minus 3 plus 1. Okay, so we have our r. We need to find our r first. Yeah. Oh, wait. U sub n is 9. Our r is negative 3 divided by 9. So we have negative 1/3. And then, oh, that's all right, because we have 1 divided by negative 3. That is negative 1/3 also. Okay, so our r there. So our S sub n is equal to u sub 1 is 9 multiplied by r is, we have 1/3 raised to n minus 1 divided by 1/3 minus 1. See now, I don't want to have negative here, so I can use instead this one. S sub n is equal to u sub 1 minus r raised to n divided by 1 minus r. That is what I'm going to use now. So we have 9 multiplied by 1 minus 1/3 raised to n, and then we have 1 minus 1/3. But as you can see here, I have we have our r is negative, so we have negative there, and then we have negative there. So that means we have 9 multiplied by 1 minus negative 1/3 raised to n. Then this will become positive, then we have 4/3 instead here. So now our formula. We have 9 times 3, because we need to find the inverse of this, or reciprocal of that. We have 27 divided by 4 multiplied by 1 minus negative 1/3 raised to n. That's our formula. Another example. Each year a salesperson is paid a bonus of 2,000, which is banked into the same account. It earns a fixed rate of interest of 6% per annum. The total amount in the account at the end of each year is calculated as follows. As you can see here, show that we have A sub 2 is equal to this one. Okay, so we have now here A sub 2 here, this one, that is A sub 1, but our A sub 1 is this. So I will put that. So I will put A sub 2 is equal to, instead of putting A sub 1, then I will put A sub 0 multiplied by 1.06, 1.06 plus 2,000 multiplied by, the whole here is multiplied by 1.06 plus 2,000. Okay, but our A sub 0 is 2,000, so we have, instead of putting A sub 0, so I will put 2,000 multiplied by 1.06 plus 2,000 multiplied by 1.06, the whole, in parentheses, plus 2,000. Then we have, if we multiply this one with all the terms, then we have 2,000 multiplied by 1.06 raised to 2 plus 2,000 multiplied by 1.06 plus 2,000. Okay, then you've already done that. Then A sub 3, of course, is A sub 3 is supposedly A sub 2 multiplied by 1.06 plus 2,000. But A sub 2 is 2,000 multiplied by 1.06 raised to 2 plus 2,000 multiplied by 1.06 raised to 1, or just 1.06 plus 2,000 multiplied by 1.06 plus 2,000. Then we have 2,000. Not 20,000, 2,000, just 2,000. Sorry. Multiplied by 1.06 raised to 3 plus 2,000 multiplied by 1.06 raised to 2 plus 2,000 multiplied by 1.06 plus 2,000. Common factor, 2,000 multiplied by 1.06 raised to 3 plus 1.06 raised to 2 plus 1.06 plus 1. Then we have that one. Okay, find the total balance after 10 years, assuming there are no fees or withdrawals. Then we need to know our N, that is 10 years, our R is 1.06, and then our U sub 1 is equal to 2,000, or A sub 0. So our A sub 10 is equal to, we have, find the total bank balance after 10 years. Then we have 2,000 multiplied by 1.06 raised to 10 minus 1 divided by 1.06 minus 1. Then this is 0.6. So 2,000 divided by 0.6. 2,000 divided by 0.06. That is 33,000. we have now, I will put here 2000 divided by 0.06 multiplied by 1.06 raised to 10 minus 1. If I'm going to count, to use my calculator to count that or solve that, 2000 divided by 0.06 multiplied by 1.06 raised to 10 minus 1. Then I have 26,000. I hope you got that also. 26,361.59. Let's see if I can show my screen. Here's what I did. 2000 divided by 0.06 in parentheses, of course, because I want them to solve first. Multiplied by 1.06 raised to 10 minus 1 in a parenthesis also. That's why I get 26,369.59. Okay, another example. This one. Consider S sub n, as you can see there, 1/2, and we have a figure here also. And then find S sub 1, S sub 2, S sub 3, S sub 4, and S sub 5 in fractional form. So we have S sub 1. We have 1/2, of course. Sorry. Yeah, it should be 1/2, but I'm going to show you. Our U sub 1 is equal to 1/2, and our R is also equal to 1/2. So if our n S sub 1, that is 1/2, multiplied by 1 minus 1/2, divided by 1 minus 1/2, and this is also 1/2. And then we have 1/2, as I've said. S sub 2 is equal to 1/2, multiplied by 1 minus 1/4 now, because 2 raised to 2, divided by 1 minus 1/2. Oh, this is also 1/2. Then we have 3/4. So this means that and that. Okay, S sub 4, 3. Then we have 1/2. As you can see here now, maybe you can see the pattern. This is always equal to 1. So for my S sub 4, then I have 1 minus 1/8. Then we have 7/8. Okay, S sub 4. Then we have 1 minus 1/16. Then we have 15/16. S sub 5 is equal to 1 minus 1/32. Then we have 31/32. From a guess the formula for S sub n, then our S sub n is equal to 1 minus 1 divided by 2 raised to n. That is our answer for B. This is B. Sorry. This is our A. Find S sub n using so our C now, we have our S sub n is equal to U sub 1, that is 1/2, then 1 minus 1 divided by 2 raised to n divided by 1 minus 1/2. And as we've seen, this is equal to 1. Then we have 1 minus 1 divided by 2 raised to n. Then we have 1 minus 1 raised to n is 1, 2. Then we'd have 2 raised to n. We found this, and it is the same like this. And then we have D now, another pen. What happened if n is very big? So we have S sub n, where n is very big. That means 1 minus 0. This will become 0. because 1 divided by very large number will become 0. And E now, what is the relationship between the given diagram and D? Here, as you can see here, if I'm going to add 1/2, 1/4, 1/8, and so on until a very small piece of the paper there, then I will have my total is the whole paper or whole figure when n approaches infinity. And this is the example, a very good example for of an infinite geometric series, okay, a convergent series, where I'm going to discuss later in my next video. So I hope you learned something in geometric series, and I hope you enjoyed it. And if you like what I'm doing, please subscribe or donate. Have a nice day. See you soon.